we're going to, a couple of warm-up problems here. We'll go through the first one together, and then we will, you'll do the second one, and then we'll get into starting to solve equations. Before I forget, there will be 3 videos for you to watch and take notes on over this weekend. And they will be more, there's 3 kinds of solving type problems that we will have. Okay? There's the basic ones where it's a singleton trig function. There's ones where it's multiple trig functions. And there's ones where you got a factor in order to solve. And so we'll start with the singletons today. There will be a short video with just a refresher on that one over the weekend. And then there will be the multiple ones and the factoring ones that you need to have done prior to your 4-mod class next week. Okay? We are getting a worksheet today too, yes. Okay? And then during the 4-mod class, we'll play Warriors Got Ninja Talent Idol. Okay? And it's a new game that I came up with. And so that you need the background information in order to be successful. Blowing her eye for her. Okay? All right. So on top here of this fraction, you see that? What do you think it? What's going through your brain other than get me the heck out of here? What? Conjugate. So that we should multiply them, right? Okay. Right. So if we multiply across the top, we get 1 minus cosine squared plus, minus cosine plus cosine, those two cancel out, and then minus cosine squared of x all over sine of x. Love it. Then you're thinking what? Now what are we thinking? What are we thinking about the top? That is sine squared of x, because it's 7, what is it, 7b or 7c? 7b? No, 7c. The last one in 7. Okay. So then this one becomes sine squared of x. And that's going to still be over sine of x. And so sine squared divided by sine is just sine. So we took this fraction and we made it just be nice and what, KB? It's nice and pretty. Yep. Just like me. Right, KB?
I know.
Well, it was the other day too. Okay. It's the theme. We're taking ugly things and making them look pretty, like me. Okay, so what I'd like you to do, oops, I went a little too far. Try that one. So the top becomes secant squared of y minus tangent squared of y all over secant of y. Now you want to, I know you do, you want to say, well, that secant squared gets canceled out by the secant on the bottom. Bless you. I know you want to do it, but can we mathematically do that? No. We could split it into 2 fractions, but even easier than that, we can say that secant squared, according to number 11, secant squared is tangent squared plus 1. Oops, almost did it again. Which means my numerator is equal to 1. Well, So secant is the reciprocal of cosine, right?
Oh, you can't change. Oh, never mind.
Right?
Yep.
So 1 over secant would be like 1 over cosine. Right? Which is just cosine. So we took that big, ugly, this is too long, says Morgan, fraction, and we just wrote it as cosine. Again with the shouting. What? Rude. Exactly. It is rude. So rude. All right. Let's do this. So, the goal of today is we want to solve trig equations. Okay? Now, when we're solving trig equations, we treat them just like I could rewrite this one as 3y minus 2 equals y, right? 3 cosines minus 2 equals cosine, right? And if I think about it algebraically, I would solve this equation by getting all the y's on one side and all the numbers on the other side, right? So we would probably do plus 2, so 2y equals 2, then we would divide by 2 and we'd get y equal to 1. Agree with algebraically solving that equation that way? That is no different than how we do the trig equations. Okay? So here I'm going to subtract cosine of x and add 2. That gives me 2 cosine of x equals 2. Then I divide both sides by 2. That gives me cosine of x equals 1. Right? Now, this part right here, that part right there is very important. It's asking you where you're, or it's, I shouldn't say it's asking you. It's telling you where on the unit circle are you going to find your answers. And so what this is saying is starting at 0 radians and going one whole lap around the unit circle and ending back at the same spot, but we're not including 2 pi in our answers. Okay? So that we get one set of answers all the way around the circle. Okay? So, on your unit circle, or on a unit circle that's around the room, where is cosine equal to 1? Cosine is x's, correct? Okay, so that's, where's my x value on the unit circle equal to 1? And the only spot that that happens is at 0. Let's offshoot another one. Okay? Same style of problem, same method of answering. Okay? So first off, I would subtract 2, and then I would subtract a cosine. That gives me, on the left side, 2 cosine of x On the right side, I get -1. Now, I divide both sides by 2. And that gives me cosine of x equals -1/2. So where on the unit circle is cosine equal to -1/2? 2 pi over 3 and 4 pi over 3. And both of those are my answers. Okay. What I'd like you to do now is I would like you to now solve that one. Square root of 2 times the sine of x plus 1. All right, so first off, I would subtract 1. Okay. That then gives me the square root of 2 times the sine of x equals -1. Then divide both sides by the square root of 2. Then that gives me the sine of x equals -1 over the square root of 2, right? Which is really negative square root of 2 over 2. If you haven't figured out yet that 1 over the square root of 2 is root 2 over 2, or 1 over the square root of 3 is root 3 over 3, you should probably memorize those two. Make your unit circle lives a lot easier. Okay? So where on the unit circle is my sine value negative root 2 over 2? I get that at 5 pi over 4 and 7 pi over 4. Okay. One last one. I'd like to do this one. 4 cosine squared of x minus 3 equals 0. Try that one. So, first off, I would add 3. Do we agree? Okay. So that gives me 4 cosine squared of x equals 3. Then I would divide by 4. That gives me cosine squared of x equals 3/4. Then what? Square root both sides. Okay. So then when I square root on the right side, I get the square root of a fraction. Do I like square roots of fractions? No. So how do we get rid of square fractions inside square roots? Mathematically wise, how do we get rid of it? Square root the top and square root the bottom. Right. Okay. So this becomes the square root of 3 over the square root of 4. What's the square root of 4? 2. So this is really cosine of x equals the square root of 3 over 2. Yes? No. What's wrong mathematically? Why is it plus minus? Yep. When we take the square root and we're solving, we have got to add in that plus minus. Okay. Which makes, and now here's why it's extremely important. If we just said that this was positive square root 3 over 2, the cosine, so that would put me at pi over 6 and 11 pi over 6. If I just go with the positive square root 3 over 2. The negative square root 3 over 2 then is going to bring in 5 pi over 6 and 7 pi over 6. So if I just go with the positive one, I only have half of my answers. Okay? All 4 of them will make that equation work. Okay? So all 4 are my answers. If you want to operate at 50%, then forget the plus or minus. Okay? But just remember, 50% is failing in most books. Okay? I know of only one where it was passing.